This is stoichiometry, mole to mass, mass to mole calculation. Before you do this or you watch this video, please go to everyday stoichiometry, mole A to mole B stoichiometry. Watch that video first. Okay, watch this video first before you watch this particular one. Watch everyday stoichiometry, mole A to mole B stoichiometry before watching the mole to mass, mass to mole calculation. Okay, so let's start with the example. Example 1. The first step in the industrial manufacture of nitric acid involves the catalytic oxidation of ammonia according to the following balanced equation. How many grams of water are formed if 2.5 moles of ammonia are oxidized? First of all, we have to understand the question. How do we know this is the stoichiometry problem? We know that because in stoichiometry problem, there has to be a balanced equation. And we have to be either calculating the quantity of the reactant or the quantity of the product. So you must understand the question before you try to solve it. So let's look at this example. So this example, we know 2.5 moles of ammonia. Oh, I have to also show the balanced equation. It's important. We look at it. So balanced equation is this. For NO2 gas plus 6 water. Okay. So now we are using this balanced equation. We must use it because it's a stoichiometry problem. Here we are going from moles to grams of water, but we can't go straight to grams of water. We have to go from moles of ammonia to moles of water. So for us to do that, we need more ratio. The mole ratio will be ammonia and water, That is 4 moles of ammonia all over 6 moles of water, or 6 moles of water over 4 moles of ammonia. Also, we have to look at, okay, with this ratio, we can go from moles of ammonia to moles of water. Then how do we get from moles of water to grams of water? Now we will need 1 mole equal to molar mass. 1 mole equal to molar mass, which will be 1 mole of water equal to molar mass of water we know is 18.02 grams of water. So we also need this 18.02 grams of water, or 18.02 grams of water over 1 mole of water. Okay. Now, I think we have to start here. Write the strategy here. We are going from we are going from moles of ammonia to moles of water to grams of water. So moles of ammonia to moles of water is, we are using mole ratio. Moles of water to grams, we are using 1 mole of, this is mess, 1 mole of water equal to 18.02 grams of water. That's what's supposed to be here. Now we want to figure out grams of water. Again, we are going from one substance to different substance. As long as you are doing that, mole ratio has to be there. Okay? So we are 2.5 moles of NH3 over 1 times moles of NH3 of moles of water, which is moles of NH3 to moles of water. I mean this one, moles of water, moles of NH3, this times, now we have moles of water here, the moles, grams of water here. So this should be 18.02, then 1 mole. This cross out, this cross out. This will be 2.5 times 6 times 18.02 grams of water all over 4. All over 4. And the answer will be what? I have to calculate this out. Where's my answer to this? My answer will be 68 grams of water. 68 grams of water. Let's look at example 2. Mercury 2 oxide decomposes into mercury and oxygen gas according to the following chemical balance equation. Okay. How many moles of mercury 2 oxide are needed to produce 125 grams of oxygen? Now again, we are calculating the quantity of the product. Quantity of the product. So in this example 2, how many moles of mercury 2 oxide are needed to produce 125 grams of oxygen? So what do? We know we have to understand the question. We are going from grams of oxygen to moles of mercury 2 oxide. So from one substance to a different substance. This balanced equation is stoichiometry problem again. So now we are starting with grams. Wow, in stoichiometry problem, you have to go from mole to mole. But because we have grams, we first of all have to go to moles of oxygen before moles of mercury 2 oxide. So how do we go to moles of oxygen? We use equivalent statements. Still applying dimensional analysis. So we go from, it will be 1 mole equal to molar mass. So 1 mole of oxygen is 32.00 grams of oxygen. That's the molar mass. Now, let's do the conversion factor here. So the conversion factors here. So 1 mole of oxygen over 32.00 grams of oxygen, or 32.00 grams of oxygen over 1 mole of oxygen. Okay. Then we look at, we are going from moles, grams to moles of oxygen and to moles of mercury oxide. So let's look at the mole ratio here. Mole ratio, which is, we write in form of conversion factor, will be, okay, oxygen and mercury. Oxygen and mercury, so that will be 2 moles of this over 1 mole of oxygen, or 1 mole of oxygen over 2 moles of mercury oxide. Now, what is the strategy? We are going from grams of oxygen to moles of oxygen to moles of HGO. So going from mole of this to mole of this, we need mole ratio. Mole ratio, here we are using 1 mole of oxygen equal to 32.00 grams of oxygen. Now, we set it up. We want to solve for moles of mercury oxide, which is 125 grams of oxygen over 1. Conversion factor, grams of oxygen, mole of oxygen. Okay, mole of oxygen on top. Where is it here? Yes, 1 mole to 32.00 times mole of oxygen, mole of oxygen, then mole of HGO. So what's the ratio here? 2 moles to 1 mole. So that's 120. That will be equal to 125 times 2 mole of HGO all over 32.00, which will be equal to 7.8 mole of HGO. That's it. Pause the video and do this practice question. It says mercury 2 oxide decomposes into mercury and oxygen gas according to the following balanced equation. It said, how many grams of oxygen gas will be produced if 2.3 moles of mercury are produced? How many grams of oxygen gas will be produced if 2.3 moles of mercury are produced? pause the video and grab your stoichiometry steps and do this. So let's look at this together. Hopefully you got it right. We underline, we circle. So now we're starting with 2.3 moles of mercury going to grams of oxygen. Obviously, we're going from one substance to a different substance, which is stoichiometry problem. Since we are starting with mole of mercury, we have to go to mole of oxygen. So let's try the mole ratio here. Mole of oxygen, mole of mercury. So mole ratio, mole of mercury will be 2 moles of mercury over 2 moles of mercury over 1 mole of oxygen, or 1 mole of oxygen over 2 moles of mercury. With this, we can go from mole of mercury to mole of oxygen. Now, how do we go from mole of oxygen to grams of oxygen? Now, we use the equivalent statement. One mole equal to molar mass. So 1 mole of oxygen is 32.00 grams of oxygen. So we will have conversion factor will be 32.00 grams of oxygen, or 32.00 grams of oxygen over 1 mole of oxygen. Okay, now we have a strategy. So strategy will be, we are going from moles of mercury to moles of oxygen to grams of oxygen. Going from mole to 1,000, we use mole ratio here. Moles to grams will be 1 mole of oxygen equal to 32.00 grams of oxygen. So we set it up. Grams of oxygen equal to 2.3 moles of mercury over 1. We will have mole of mercury here, mole of oxygen here. Where is mole of oxygen? 1 to 2. Then now we have mole of oxygen here, grams of oxygen here, grams of oxygen is 32.00, then 1 mole. We cross this out. We cross this out. That will be 2.3 times 32.00 gram oxygen over 2. 2.3 times 2.00 grams of oxygen over 2. That should be equal to 3.7 grams of oxygen. Okay. Now, you do more practice questions. The first step in the industrial manufacture of nitric acid involves the catalytic oxidation of ammonia according to the following balanced equation. Then, how many moles of NO are formed if 824 grams of NH3 react? How many moles of NO, nitrogen monoxide, are formed if 824 grams of ammonia react? Then how many grams of NO are formed if 5.50 moles of NH3 react? How many moles of oxygen are needed if 25.8 grams of nitrogen monoxide are formed? Pause the video and try these 3 questions. Okay, let's try this one practice question. How many moles of NO are formed if 184 grams of NH3 react? So we underline and we circle. Then we are going from grams of NH3 to moles of nitrogen monoxide. Yeah. So one substance, a different substance, it is stoichiometry problem. Stoichiometry problem. So we start with, we have to make this, change this to moles, because we can't go from grams to, we can't change if we can't change it to if without converting to mole. Remember, mole is like a bridge. So the equivalent statement we need here, I write it on this side, is 1 mole per molar mass. We have to first of all change it to we get molar mass of NH3, which will be 17.04 grams of NH3, which will be 1 mole of NH3 over 17.4 grams of NH3, or 17.04 grams of NH3 over 1 mole of NH3. So now, we first of all have to convert grams of NH3 to moles. Then we go from moles of NH3 to moles of NO. So mole ratio. So look at balanced equation, mole ratio NH3 and did I mess up in this equation? And let's see. So this is NO, not NO2. I messed up there. So mole ratio is 4 moles NH3 over 4 moles of this, or 4 moles of this over 4 moles of NH3. Now, then we have the strategy. Let's see. So the strategy, we are going from grams of NH3 to moles of NH3 to moles of that. So this will be 1 mole of NH3 equal to 17.4 grams of NH3. Then this will be mole ratio. Okay, so we want to calculate mole of this. We know 184 grams of NH3 ammonia over 1. Then we repeat the same unit here. This will be mole. So mole, each one matches 1 mole over 17.04. Then we go from mole to mole, which is mole of NO gas. So which one matches that? Okay, this cross out, and that should be 184. This will cross out. 184 times 1 mole of that divided by 17.04. That will be 48.4 mole of that. So then this is the answer to the second and third question. So try your best to get them right. Grab your stoichiometry steps and follow it. You can't get it wrong. Thank you.